Hello, sir. Myself Manoj, and here Prashant and Akshay, and we have designed a project digital tachometer using IR sensor with Arduino for measuring RPM. And the operating voltage we taken is 3.3 volts to 5 volts, and detection range is to 2 centimeters to 30 centimeters, and current consumption is 3.3 volts to 23 milliamperes, and 5.5 volts to 43 milliamperes. And the active output level is output low logical level when an obstacle is detected. On board, obstacle detection LED indicator. Next slide. And the objective of the project is that tachometer is an RPM counter which counts the number of rotations per minute. And there are two types of tachometer, one mechanical and another one is digital. A digital tachometer circuit comprises LCD or LED, readout and a memory for storage. Digital tachometers are more common these days and they provide numerical readings instead of dials and needles. A digital tachometer is an optical encounter that determines the angular velocity of a rotation shaft or motor. And what is a tachometer? A tachometer is a device used to measure the rotational speed of a motor or other rotating object. One way to measure rotation speed is by using an IR sensor, and it detects the presence of teeth or other features on the rotating object. By counting the number of pulses and measuring the time elapsed, the rotational speed can be calculated in RPM. Next slide. And the importance to measure the rotational speed of a motor or other rotating object. It is important to measure the rotational speed of a motor or other rotating object for several reasons. And coming to the performance monitoring, measuring the rotation speed of a motor or machine can help the monitor and its performance. And they can detect any potential issues or malfunctions. And coming to the quality control, by manufacturing, measuring the rotation speed of machines and production lines, and that can be ensure that the products are being produced. And this can improve overall product quality and customer satisfaction. And the main important is safety. In some applications, such as in heavy machinery or vehicles, measuring the rotation speed can be critical for ensuring the safety of operators. And overspeed conditions can cause equipment failure, which can result in serious injuries or even facilities. And coming to the energy efficiency was taken by the tachometer is used to measuring the rotational speed of motors and other equipment can help optimize their performance and energy efficiency. This can result in significant cost savings and reduce environmental impact. And coming to the basic working principle of an IR sensor. An IR sensor works by emitting an infrared light beam and then detecting the amount of light that is reflected back. When object is in the path of emitted light beam, some of the light is reflected back to the sensor. The amount of reflected light that is detected by the sensor depends on the distance and reflectivity of the object. And IR sensors can be designed to detect either proximity or reflectivity. And coming to the sensor used to detect the presence of an object within a certain range, while reflectivity sensors are used to detect the amount of reflected light from a surface. In the case of tachometer with IR sensor, the sensor is typically positioned near the rotating object and it is aimed to a reflective surface, such as a toothed wheel or tape. As the reflective surface passes by the sensor, it reflects the emitted light back to the sensor. And the frequency of the pulses corresponds to the speed of rotating speed, which can be measured and used to calculate the rotational speed in RPM. And the IR sensor and the lead emitter, as shown in the figure, is represented by the Nitya Prashant.
Good morning, sir. My name is Prashant, and I will be carrying in the presentation from here on. As we can see in the diagram, there are two boxes type structures, which is a emitter and another one is a detector. As shown, An IR sensor typically consists of two components. The emitter emits an infrared light beam which is directed towards the object to the to be detected. When the emitter light strikes the object, some of it reflected back towards the detector. The detector senses the amount of reflected light and generates an electrical signal, which can be used to determine the presence, proximity, or reflectivity of the object. Note that there are many different types of IR sensors, and the exact configuration and components used can vary depending on the specific application. This is just for an example. And here is the hardware photo of the IR sensor we prepared. And furthermore, the components and the code will be seen in the next slide. This is the 8051 example code for the working of this tachometer. This is the Arduino code which is used in the Arduino processor of the hardware. We took it from the net. And here this is the video of the execution of the hardware. It is executed by M.MANOJ. Here keeping by moving the finger across the sensor, we got the RPM as 24, means the he is moving 24 times for a minute, and it's calculated, so it took some time. And list of the components required for building a tachometer with IR sensor. These are the requirements to build a tachometer with IR sensor. The following components are typically required. IR sensor. An IR sensor is the main component used to detect the speed of a rotating object. Reflective surface. Here we used finger, but reflective surface is also can be used. A reflected surface is attached to the rotating object, such as a toothed wheel or tape, or reflect the IR to reflect the IR light back to the sensor. Microcontroller. A microcontroller is used to process the signals from the IR sensor and calculate the speed of the rotating object. Here in this case, we use the Arduino as microcontroller. Display. A display is used to display the calculated speed of the rotating object, such as an LED or LCD. Power source. Power source is compulsory. Then supporting components as resistors, capacitors, and transistors may be required to build the circuit. Here in our hardware case, we use it breadboard. Here we use breadboard, resistors, and connecting wires. These also come under the other component section. And applications and advantages of tachometer with IR sensor. Tachometer with IR sensor are widely used in various fields to measure the rotational speed of a rotating object. These devices are used in industries such as automotive, aerospace, and manufacturing to monitor the speed of machines and ensure their smooth functioning. Tachometers with IR sensor work by detecting the infrared light emitted by a rotating object and measuring the time between the pulses of light. This information is then used to calculate the rotational speed of the object. One of the main advantages of tachometers with IR sensor is their accuracy. These devices can measure the rotational speed of an object with high precision, making them ideal for use in applications where accuracy is critical. Another advantage of tachometer with IR sensor is their versatility. These devices can be used to measure the speed of a wide range of rotating objects from small motors to large turbines. Tachometers with IR sensors are also easy to install and use. This typical They typically come with user-friendly interfaces that allow operators to quickly and easily set up the device and start measuring the speed of a rotating object. Additionally, these devices are often compact and portable, making them ideal for use in a variety of settings. Thank you. Akshay will be carrying on from the next slide.
Good morning, sir. My name is AKSHAY. Today I am saying about limitations and challenges of using tachometer with IR sensor. When combined with an infrared IR sensor, tachometers can provide accurate readings without requiring physical contact with the rotating object. However, there are several limitations and challenges associated with using tachometers with IR sensor. One of the main limitations is the distance between the sensor and the rotating object. IR sensors work on the principle of reflecting infrared radiation emitted by the object. The further the sensor is from the object, the weaker the signal it receives, which can lead to the inaccurate readings. Additionally, the sensors must be positioned at a specific angle to the rotating object, which can be difficult to achieve in some applications. Another challenge is the type of material. The rotating object is made up of IR sensor relay on the object, emitting infrared radiation, but some materials such as shiny or reflective surfaces can reflect the radiation away from the sensor, leading to inaccurate reading. Finally, environmental factors can also affect the accuracy of tachometers with IR sensors. Changes in temperature, humidity, and lightning conditions can all impact the readings, making it difficult to obtain reliable data. Literature survey related work. Title or publisher digital tachometer using Arduino. Authors S. D. Harsha Kumar, C.H. Venkatesh. Year of publication 2019. Methodology. This paper describes the method of using sensors in digital tachometer. Advantages. It gives us more clarity about our project. Drawback. Overview is not in much clarity. Non-contact tachometer using laser and image processing techniques. Author published by the Canadian Society for Mechanical Engineering. Year of publication 2014. Methodology. The article covers details about how accurate digital tachometer measure for the given input. Advantages: the ability to change units of measurement, recall past readings, and view minimum maximum measurements. Drawbacks: the major drawback is getting perfect accuracy all time is not possible. Digital tachometer design and calibration. Edited by John G. Webster, published by Willie in the year of publication 2017. Methodology. This paper describes the method of using of proximity sensors in digital tachometer. Advantage: the P5 to 11 proximity sensor is a rugged industrial two-wire probe style inductive sensor. Drawbacks: the data obtained from the sensor is usually interacted with extreme interfaces. Development of high accuracy digital tachometer for rotating machinery, published by the Canadian Society for Mechanical Engineering in the year of publication 2014. Methodology. This article covers details about how accurate the digital tachometer measure for a given input. Advantage: the ability to change the units of measurements, recall past readings, and view minimum, maximum, and average measurements. Drawback: the major drawback is getting perfect accuracy all time is not possible. A study on the application of digital tachometer in the automotive industry, published by the Society of Automotive Engineers in the year of 2015. Methodology. Tachometers can be used for various types of equipment in a number of settings, such as conveyors, grinding mills, rotary feeders, grinders, dryers, cooling equipment, and elevator. Advantage: it is used to show the number of revolutions per minute of the aircraft engine. Drawbacks: the information is not connected to IoT, so any information not recorded in any database. Research gap. In this project, we have designed digital tachometer using an IR sensor with Arduino for measuring the number of rotations of the rotating module in RPM. The IR sensor module consists of IR transmitter and receiver in a single pair that can work as a digital tachometer for speed measurement of any rotating object. IR transmits IR rays which reflect back to the IR receiver, and then IR module generates an output or pulse which is detected by the Arduino controller. When you press the start button, it counts continuously for 5 seconds. You can also make fan measurement device as well as GPS speedometer. Block diagram or methodology. In this circuit, the IR sensor module is interfaced with Arduino to measure fan rotation speed in RPM. The calculation is done on the basis. After 5 seconds, Arduino calculates RPM per minute using given formula. RPM equal to count into 12 per single object rotating body. But here you demonstrate this project using a ceiling fan. So we have done some changes that is given below. RPM equal to count into 12 by objects. where object equal to number of blade in a fan. References, links, books, journals, conference papers. Thank you.
Hello sir, here we designed a tachometer which shows RPM on LCD display. We used IR sensor. Here the principle we used, that is 10 iterations time to calculate time. Here is the following way with the reading RPM